Hello, my name is Joel. This is our new Peter and Josh, and together we're the Smart Motorcycle Personnel Controller team. Me and Peter did coding for the microcontroller and also for the filtering algorithm. Our new code created the relay circuits, and me and him also designed the PCB. And Oscar and Josh worked on the wireless helmet notification. In 2007, according to the National Highway Traffic Safety Administration, there was approximately 7 million motorcycles on the road. This number has continued to climb at a rate of approximately 9% every year. With so many motorcycles on the road today, safety has become a major concern. This is especially true since motorcycle crash is 6 times more likely to be fatal than a car crash. This was, because of this, motorcycle riders always want to alert other drivers of their actions. This was a major inspiration for our project, which was to create a smart motorcycle turn signal controller that would give motorcycles features that they currently lack. One would be hazard lights. Most motorcycles currently do not have this feature. Another would be auto cancellation of the turn signal. And a third would be a wireless helmet notification to the rider's helmet that would allow them to know whenever the turn signal was engaged. To do this, we implemented the design on an Arduino Uno prototyping board. We're taking in data from 2 momentary switches. Whenever either of the switches is pressed, the turn signal is enabled, and a wireless signal is sent to the rider's helmet to enable the notification system. Once this happens, the controller begins taking in data from the gyroscope and accelerometer, and it uses this data to calculate a lean angle. This angle is used to know whenever the motorcycle is currently performing a turn, and it also used to shut off the turn signal once the turn has been completed. We also then send a signal to the helmet again to cancel the notification system. For this semester, the goals that we set out to perform, we were able to accomplish most of them. We were able to program the microcontroller to accept input from both the momentary switches that would act as the left and right switches on a motorcycle. We also enabled hazard lights, which it goes into this mode whenever both the switches are pressed simultaneously. We were also able to calibrate and gather data from the accelerometer and gyroscope, and also implement the filtering algorithm that filters out 9 idealities in the right condition. We were also able to implement a wireless notification system to the rider's helmet, and also implement a relay circuit that helps to power the filament type bulbs that most motorcycles use today. We were also able to create a PCB. However, because of our inexperience and issues and delays that arose along the way, we were unable to get our design fully working on the printed circuit board. However, we believe that given additional time and the knowledge that we have gained from the mistakes that we have made, we would be able to accomplish this task. We do, however, have a working prototype that we would like to invite you guys to visit out of the poster session after the presentations. Now, is there any questions?
How much modification the helmet is make?
Well, right now, you don't have to do much. Right now it's on a breadboard, even on the helmet, but I mean, we're running it off our Arduino microcontroller, but I mean, we could make it very small, that would actually make it where it doesn't take too much width in the helmet, and it could actually, there's already enough padding in the helmet where we could actually route the wires and we already have a really thin speaker that actually, your head can go in and when you really feel it.
So what's the advantage of having it in the helmet versus chassis?
Well, if you had it on the chassis, we would have to make it really loud, just because like if you are riding a motorcycle, there's a lot of road noise. So and also
the helmet for audio.
yeah, it's an audible signal, since we didn't want to have any visual signals to distract the driver or the rider.
What kind of channel isolation was it to prevent two side-by-side interfering with each other?
Right now, the only thing we're doing is we're making them addressable. So we're creating a unique address, and then after we're bicycle over there, and it actually worked pretty well. We did have to adjust the angles because, it's a lot slower, so it's only about 13 degrees, we're calculating about 5 miles per hour. But that seems to work pretty well.
So it's sensitive to location on one side.
It's sensitive. It has to be placed horizontal, just because of the sensors that we're using. But it could be placed pretty much anywhere, as long as the angle is matching with the vertical. That's what it's sensitive. It's like the only caveat is it does have to be horizontal on the motorcycle. Just because we actually do run algorithm whenever the motorcycle is turned on to verify the zero level for the voltage.
Did you verify the logical location there on your side?
Yes, actually right underneath the seat. I did have to, because of the size of it right now, I did have to relocate the actual computer for the motorcycle. But obviously, we would try to make it as small as possible so it could just, be placed in more locations.
So currently, does a motorcycle use one of these switches to signal that?
Currently, it uses 2.
So you have
Yes.
switch it on the left and right?
Yes. I mean, we would be able to use it with, the type of triple switch where it's like left, right, and then you push in to shut off. So we could also implement it with that, but right now, just because of time, we just made it voluntary.
How about lane change? Because this doesn't seem to work well.
No, just because of lane change, I mean, the angle that you have in a lane change isn't enough. So right now, at this time, our system wouldn't be able to know if you were making a lane
So
change.
did you brainstorm that at all?
We did. The main issue that we wanted to fix was pretty much just people forgetting. I'm a motorcycle rider and I forget all the time, as well as I have seen others forgetting that you have your turn signal there and then just leaving it on, and then people not knowing what your move is going to be or your current action. So that's even now we know that system's not going to be 100% effective. So that's why we also implemented the wireless help notification. So even if for some reason you make a turn and it doesn't shut off, you're still aware that your turn signal is on, so you can manually turn it off.
Much larger without a home.
Yes, I mean,